Hello and welcome to the show. Today's challenge is an overheating home theatre cabinet. Whether it's a computer cabinet or a audio cabinet, they can get very hot depending on how many components you've got running in them, and if they get too hot they'll fail. So what we want to do today is build a module that will run two temperature sensors, detect the internal temperature of the cabinet, and when things get too hot, activate a fan to cool things down. For today's project we'll actually use an Arduino. This is an Arduino Uno R3, and this will be the basis for the day's project. So let me take you through the components, the parts that we'll use for this project, and we'll start to assemble it. So these are the parts here: 12 volt fan, just a normal everyday computer fan. It's a 200 milliamp model, 80 centimeter fan. The actual little wall wart or plug pack, wall wart for our American friends. So this particular plug pack's 12 volts and 0.4 amps. So 400 milliamps out of that is just going to be enough. Probably should use a little bit more, but I think we'll be okay. And the reason I say that is 200 milliamp draw out of the fan when the fan's actually running. An Arduino by itself, so just one of these boards all by themselves really only draw, they draw about 45 to 50 milliamps. So you need to take that into account. So 50 milliamps out of the board, 200 milliamps out of the fan, and the MOSFET. So this is a MOSFET, I'll talk about that in a second. Plus the two LM35s will actually have potentially another 50 milliamp draw going through there. So we're up around the 300 mark, maybe 350, and you never really get a full 400 out of something like that all the time, but yeah, we should still be okay. So the idea is that the microcontroller, the Arduino, and I will be using the entire Arduino. I'm not going to take out the microcontroller, the ATmega328, and put it on a breadboard or anything like that. You can, but for my purpose here, I actually want the entire microcontroller, and these aren't too expensive at the moment, so I'm going to use all of that rather than make my own circuit. So microcontroller will sense the temperature from the LM35s. Now this is an LM35. I'll give a close up on that one. So there we are, LM35 standard temperature sensor. Okay, so that is identical to this. Should still be able to see LM35 on there. Yep, there we go. Right, it's identical to this. It's just put onto a very convenient breakout board. So we can use a standard 3-pin cable here. And the reason this is actually more advantageous is that this is nice and easy to mount via the extension cable, the breakout cable, inside the cabinet, and have the other one outside the cabinet. So you can basically just install these almost anywhere and still get the reading going through to the Arduino. So I'll be using two of those, and the last component is this MOSFET. So field effects transistor, and this particular one is upside down. Alright, there we go. So this is capable of 60 volts DC at about 20 amps. And you can buy these individually, of course, but again, this is already on a breakout module, and the passives are already installed. It's just for convenience more than anything else. So if you're going to make it easy for yourself, why not? So that little MOSFET is the power supply that we'll actually be using to power the fan. Right, and the reason that you can't just plug the fan directly into the Arduino is because it doesn't have enough power. So from the output pins on the Arduino, you can power certain devices, certain components, but the output pins on the Arduino are only good for about 20 to 30 milliamps. Just have a look at the Arduino website to get the actual accurate number, but it's around 20 to 30 milliamps. 200 milliamp fan, it's not enough power coming out of this, you'll just cook it. So what we need to do is we actually need to run power through the MOSFET which will easily power that fan, and use one of the pins as a trigger pin. And the trigger pin is what the signal will come from the Arduino to the trigger pin. So it will either be low or high, positive voltage or no voltage. So that will trigger the MOSFET and allow power to flow through, right, and complete the circuit for the fan, activating the fan. And we'll cover that in more detail in a second. So that's basically the circuit that we'll be putting together. It won't be very elaborate, but it should do the job. I wanted to talk a little bit more about the portable power supply we made in the previous episode. One word of warning, depending on what reference you find and you look at, the safe DC working limit is 42 volts. And obviously with the 4 9-volt batteries that we used in this example, we're up around the 40 volt mark. So if you're just not ready for working with something like 40 volts, or you're not confident about your own safety, just maybe hold off on this project, or alternatively drop the 4 9-volt batteries down to 3. You'll still get a 25 volt power supply, which is potentially more than enough. So yeah, just that word of warning, 40 volts is up toward that threshold of what they consider a safe DC working limit. Another thing about this, when I put this together, I knew what I was going to be using it for, powering microcontrollers, some LEDs, little projects and things. So the heat that will be generated by this, so this has got 40 volts, basically 40 volts of DC power pack going into the 317. If you're asking, say, 5 volts out of this, which it will do, that's a 35 volt difference. At least 35 volts, or yeah. So if you're asking 1 amp, and this will do 1.5 amps out of a 317T. So if you're asking, say, an amp, you're driving something that draws an amp, and there's a 30 volt difference between the batteries that you're putting into the 317 and the power that you want out, then that difference is going to be generating heat. And in that example, 30 watts of heat. The heatsink and the setup I've got in there is probably good for about 5. So if you're powering microcontrollers, small devices, and low current, and for a short time, this is fine. If you're going to be asking the full range of what this is actually capable of doing, the heatsink that I used in this example is nowhere near enough. You need to, something 6 times or 10 times the size of that, and or potentially run a fan. And I've actually got a fan I thought about putting into this one. The last point I wanted to talk about was the resistors themselves. I've used stock standard, again, because I knew what I'd be using it for. I've used stock standard 0.25 watt resistors. And if you're going to be asking much out of this, they're not enough. So if you wish to, like I said, an amp, something like DC motors or something like that, you're going to need to increase the resistor wattage, because you'll burn the 0.25 watt resistors out. So what I'd like to do, I'll just wait for your feedback. If you want to just see this thing taken through to destruction, I'll put a decent load on there, put the thermo probe on it, let it heat up and show you what it takes to actually cook an LM317T, all the resistors that are in this exact circuit. Let me know. If you'd rather that I revisit this with maybe a switch mode, voltage regulator, or just increase the heatsink, put a fan in there and upgrade the resistors, I'll wait for your feedback. So I'm not actually going to be installing this into any particular sort of case. I'm actually just going to mount it onto a board and place the board exactly where I need it. And this is just an example that you don't need a 3D printer, you don't need routers, you don't need all of this fancy gear for some simpler projects. All this is 3mm MDF board, and I'm just going to use a Stanley knife and cut out the size of the piece that I need and mount my components onto that. So just draw what you need and then run the Stanley knife over your lines, right, with just not too much pressure to begin with. Right, and just make a scoring mark and just do this in any orientation that you feel comfortable with. I'm not overly comfortable going this way, but I've got the camera in my way. Right, And that's it. You just continue scoring along and you basically just snap this piece out. Okay, so all I've done here is just cut that piece of MDF out with the Stanley knife and drawn an idea of where I want the fan to go. I'll probably throw the Arduino and other wiring, etc. in here, and one of the LM35 sensors will probably go somewhere around there. I've got plenty of other room for passive components, wiring, and a couple of mounting holes I'll put in the board toward the end. And of course, yeah, the MOSFET's got to go somewhere too. Alright, I'll make some holes in here now so obviously the fan can blow air through, and then we'll start putting some things on the board and wiring them up. Okay, this is the piece of board I've made a cutout for the fan. So the fan will realistically go here. I'll probably mount the Arduino somewhere down there on the board. Arduinos do come with some screw holes already in them. Makes life easy. I'll run a terminal block up here. I've got this 9-volt battery holder with the barrel jack on it, which is already suited to the Arduino. So I just cut the ends off here and I'll take the power out of the terminal block and just straight into the Arduino there. So it'll take 12 volts through that barrel jack. So the other components, I'll run one of the temperature sensors down the bottom, and that'll connect via one of these types of leads. Right, straight into the Arduino. I'll just make up a connector. This one will be on the inside of the case itself, so it'll be out of sight, and this will just come up through this hole in the board and connect again to the Arduino. And the MOSFET I'll probably mount somewhere up here. So I've got plenty of room on the board, and I'll just mount the parts where I feel nice and spacey and not too much in the way. I'll affix a few of these components to the board now and start connecting some of the wiring, but I won't get into the details of how the MOSFET's connected up or how the LM35s actually connect to the Arduino. I'll get to that in a minute. So I've progressed a little further in putting this together on this MDF board. Put a little terminal block in there just to get the power from the plug pack to come into the overall circuit. This won't be permanent. These are fine for getting your prototype working, but in a more permanent fixture you probably don't want this, even though, like I said, I'm going to use the entire Arduino here. So I've got this powered up at the moment, coming through the barrel jack of the Arduino. This is measured at about 13.2 volts coming in. This is still okay for the Arduino through the barrel jack because it's actually got a voltage regulator on the board. So I'll power that up quickly. And as you can see, I've got power coming through, and I've got a faster version of the Blink sketch running on there. So I'll just continue on, mount this to the board, mount the fan to the board. Got the little cutout there, let the air flow through, and start looking at the LM35s and the MOSFET. Now we've got the power going to our module, our product, and we've got the Arduino sitting there, and the fan for the most part is hooked up. We'll have a closer look at the MOSFET, this little sucker here, and the LM35 temperature sensors and how they actually work before we go any further. Let's have a look at those in more detail now. Okay, so what we've got here is actually the Freetronics website, and this is the actual MOSFET that we're using in our project. So as you can see here, the digital output pin connects to the first pin as we look at the product. Right, so G, it's marked as G. So the output connects to G. This is the fan circuit. So we have positive power coming into the fan, and the negative of the fan circuit connects to the center pin of the MOSFET, or the MOSFET module, D, and the S on this MOSFET module connects to a common ground. So ground on the Arduino, ground on the MOSFET. Negative power from the MOSFET center pin is the negative of this circuit over here, and that will power the fan. So the digital pin coming out of the Arduino, and this is what we'll program into the Arduino, power on, also signal high from the Arduino will allow power to flow through the MOSFET and therefore power the fan. Signal low, so a 0 pretty much, coming from the Arduino will close the circuit and not allow the fan to actually operate, and that's exactly what we want. Okay, so this is the DF Robot website, and this is the exact LM35 version 2 analog temperature sensor that we're using. So if we have a look at, don't really need the data sheet on this one, although if you look at the website you can obviously get a lot of information about this particular module. The important part to note on this one is that this is the new version. So power in is the center pin and the ground is the bottom pin. And if you actually have a look at the cable that the actual sensors come with, you can actually see that center pin is power, the red cable, and the black at the bottom is the ground, and the blue is what we want to go to our sense pin or our analog input pin on the Arduino, and we'll cover that now. Okay, I've got our Arduino hooked up. I've got one of the temperature sensors hooked up, and this is the Arduino code that I'll probably be using. So I'll just walk you through what I've got. So a couple of constant integers have been declared, so external LM35. The input of the LM35 is going to the analog 0 pin. The external LM35, so this is the one that's not inside the cabinet, external LM35, and I've got that to going to analog 1. And the fan trigger, or trigger fan, I've declared that, and I'm going to use the digital pin 7. So again, just some more integers here. Sensor value 1, sensor value 2, the output value 1 and the output value 2. I'll get to those two in a minute. So the start of our loop, and I've got the serial begin coming in, just so I can see the serial data on the screen before I actually hook up the final project. Just make sure everything's working right so I can see it on the screen. So starting off the void loop, so in here, read the sensors. So sensor value 1, read from the analog pin, external LM35, which is really just at the top of the project, as you can see. LM35, external LM35 is just analog 1, analog 0. So analog read from analog 0, analog read from analog 1, and that's the external and that's the internal. So output value equals sensor value multiplied by 0.4888. This value here is simply a easy multiplication of the 5 volts that the sensor is rated at. So you're putting 5 volts in, and there's a I think it's 4-bit resolution. So what that basically means is 5 volts going in, 1024 possible output of anywhere between 0 and 1024. So if you use the 1024 divided by the voltage that you're actually using, and then divide by this number here, and that will give you actual temperature in Celsius. It's not perfect, but it's a fairly accurate representation. So just to be able to see something coming out of the circuit, we've got some serial.print lines here, and that will simply put the serial data, so the LM35 sensor reading, out on the screen. So I'll upload this to the sketch. Upload this sketch now to the Arduino. Loading, loading, loading. Okay, loaded. So the Arduino's happy with that. So if we open up our serial monitor, Put our serial monitor there. So as you can see, it's updating every 1 second. So the sensor reading, and I'm only reading the external sensor at the moment because I haven't hooked up the internal sensor. So, but the principle is exactly the same. So the external sensor, this is a analog reading, right? This is not Celsius. This is just the way the analog data is presented from the LM35 into the Arduino pin. So this is the temp. So this is this number multiplied by the 0.4 figure to give a variation of Celsius. So if we keep watching down here, we keep watching this variable, this value here, I'll just grab hold of the actual sensor, and as you can see, the numbers climbing from 21 straight up to about 28, 29 degrees. So that is the way this sensor will measure temperature. So if I hook up 2 of those, one inside the cabinet, one outside the cabinet, as soon as there is a variance between the two, so the outside temperature will be the reference voltage or the reference temperature, and the internal temperature will be measured by the other sensor. As soon as there's a significant difference between the two, I set the digital output pin to high, which will activate the fan going through that MOSFET. Okay, so this is the final Arduino code. So the constant integers declared up top, the analog pins for the LM35s, the digital pin which will simply be on or off, which will activate the MOSFET and therefore be driving the fan. Sensor values and output values, I've talked about those already. All I've added here is digital write fan low. So basically at the start of the program, it makes sure that the trigger to the MOSFET is turned off, so the fan's not running. So the void loop, and all I've really done here is added an if statement. So if output value 2, which is really just the internal LM35, so if the internal LM35 is reading higher than the external LM35 plus 3, so in other words, if the internal temperature is higher than the external temperature plus 3, digital write trigger fan high, so turn on the fan. Otherwise, turn the fan off. Now this extra stuff at the bottom, right, just move it up a bit. So I've got some serial write data down here, which is just again to put the things on the screen. I don't need this in the final version, so you just rem those out or just delete it completely. And I'll upload this sketch to the Arduino. Hopefully there's no errors. Zoom out a little bit. No errors. So if I turn on the serial monitor now, okay, the external temperature sensor, so the LM35 outside of the cabinet is reading 20. The LM35 inside the cabinet is reading 22. Now if this goes 3 or so degrees higher than this one, the trigger should turn into a 1. So I'll grab hold of this temperature sensor now. Make sure you can see that. Yep. So I'll grab hold of the temperature sensor now, and the trigger value should turn to a 1. Okay, so temp's gone up to 25. There you go, straight away. Turn to a 1. So in principle that works. All we need really now is to complete the circuit, hook up the actual fan, and we're pretty much right to install it into a cabinet. Okay, we've done our coding for our Arduino. Now we'll just hook up the 2 temperature sensors in a bit more of a permanent fashion and get the MOSFET connected up, pretty much the same way you saw the wiring diagram before. And it'll be right to do some final testing, and then if everything's good, put it in the cabinet. Okay, I finished the coding and there was one small mistake. for the output pin, the digital pin 7 in that code, you do need to set the pin mode to output. If you don't do that, there's no actual voltage coming out, therefore it won't trigger the MOSFET. So I think we're pretty much done. I've finished the circuit and let's just test it out now. Alright, so here's the circuit. Most things are bolted in enough. MOSFET's been wired up. Grounds all connected, everything's right to go. This is the internal sensor, this is the external sensor. So if this gets 3 degrees warmer than this one, the fan will activate, cooling the inside of the cabinet. I've got this set to a 3-second interval at the moment. Obviously once that's in the cabinet I won't set it for 3 seconds, I'll change this to probably a 30-second interval. So it'll test the temperature every 30 seconds and then activate the fan accordingly. Power up. Okay, so Arduino's getting power, everything else is connected, so it all should be working, and the ambient temperature in the room is about 22 degrees. I'll just hold my hand on this sensor, and once there is a 3-degree difference, there we go. And that fan is putting out quite a decent amount of air. Right, let go of the sensor, and in 3-second testing intervals, or better yet, just heat up the ambient temperature. There we go. All shuts down. So there you go, a little board with an Arduino and a few other components to be able to measure the internal temperature of a cabinet versus the external temperature of a cabinet and activate a fan. Next week, I'll stay on the Arduino theme, and we'll actually be using an Arduino to tell whether or not your garage door has been left open, or use your smartphone and double check whether or not the doors are open or closed, and also set it up so that it will send you an email reminder after a predetermined amount of time if you've inadvertently left your garage door open. Thanks for watching.